Hello, today I am going to share with you about down counter. So in my previous video, I talked about up counter. So up counter and down counter is almost the same in terms of principal operation. The only difference between the two is the up counter will cause the accumulated value to increase when it is energized by pounds. Whereas for the down counter, the accumulated value will be decreased when it is energized by pulses. Alright, so let me uh, create a new file here. Okay, maybe I will create a few run and then I will insert virtual switch, and then here I will select down counter. Alright, okay, this one I will use binary 3 column 0 slash bit 0. Okay, this one may be pulse input. All right. Okay, counter, I give an address. Okay, down counter. Okay, the address should start from C5. Okay, then C5 column 0. Okay, you can use any number, not only 0. Can use 1 or 2 or 3 up to 255. All right. All right. Okay, the preset value is a set point. So set point example, maybe I put 5. Okay, accumulated value, maybe you can put any value. For example, in today's video, maybe I put 10. Okay, so this I will copy the virtual switch here. This one I will change to other bit number. Okay, this one maybe I will say, okay, down counter trigger. Okay, and then the output virtual output coil. Okay, maybe I use digital output column word 0 slash bit 0. Okay, maybe description I will say moto. Okay, and then this one, make sure I copy this to here, and then I will use counter. Okay, I will use never mind, I use maybe other bit, maybe bit 2. This I will say reset pulse or pulse reset. Okay, and then this one I go to timer or counter tab and I select reset here. Okay, so to reset which counter? This counter. So I might use the same address as the counter address. Okay, all right, so now I will compile a file to make sure there is no error. Then I click here and then select download, and then you can save into your hard disk. Okay, save into any directory that you want. I will give a file name. Maybe I will say down counter. Okay, okay, here I select run. Okay, maybe I put here a bit. Okay, this I can use binary, for example counter here. Okay, so you can see here, so what will happen is if I trigger this binary virtual switch from normally open to close, the virtual power will flow through this run to energize this down counter. Once it is energized, the CD bit will be energized, right? Will be activated. Okay, so how this counter work is very simple. Whether it is a down counter or up counter, as long as it is a counter, if the accumulated value is equal or higher than the preset value, the done bit is always activated, and vice versa. In other words, when the accumulated value is lower than or lesser than the preset value, this done bit will be deactivated. Okay, so this is a very important concept that we have to understand. Now you can see the done bit is activated. Why? You can see the accumulated value is higher than the preset value. That's why the done bit is activated here. Okay, so I'm sorry I make a mistake here. This I supposed to use the counter address. So let me go to offline, and then I will change the address. For this one, sorry, cannot change like that. I will double click, and then I will change the address, counter find column 0. I will use done bit slash done bit. Okay, this I will say, okay, CTD mean down counter trigger. Alright, click OK. Okay, then compile the file, make sure no error, then download one more time, and then click run to run the program. Okay, as you can see, is there, because the accumulated value is higher than preset value, or the done bit will be activated. As you can see, that is 11 virtual switch, which is C5 column 0. Okay, done bit for this one, C5 column 0 done bit is activated. So this will be triggered for normally open to close. If this virtual switch is originally normally closed, then it will be activated or triggered from normally closed to open. Alright, since this is a normally open, so it will be triggered to close. So what happened, the virtual power will flow through this rung to energize the virtual output coil. Thus, it will then activate the external load, in this case motor, meaning it will turn on the motor. Okay, so if I continuously supply the pulses, okay, you can see this is trigger, is activated, the CD or down counter bit is trigger, is activated, and you can see the accumulated value is decreasing. Why? Because it is a down counter. Down counter will decrease the accumulated value, up counter will increase the accumulated value. So one more time, you can see what will happen to the accumulated value. See, it decreased. All right, so I will continuously supply pulses until the accumulated value lower or lesser than preset value. You can see what will happen. The done bit will then be deactivated. Okay, now it's number 5. Okay, see what will happen. See, the accumulated value is lesser than the preset value. The done bit will be deactivated. Thus, the relevant virtual switch will be normalized, or okay, and this normally open will remain open. Thus, no virtual power to energize the virtual output coil, and the motor will remain off. Okay, how to reset the accumulated value? Simple. I just need to click here and supply the pulse to the reset instruction. This will be reset to 0. Alright. Okay, for your information, this preset value can be negative value also if you want. Let's say negative 5. Okay, so okay, so accumulated value is 0. Preset value is negative 5. Thus, the accumulated value in this case is actually higher than preset value, which is negative 5. As I said before, whether it's a down counter or up counter, as long as the accumulated value is equal or higher than preset value, the done bit will be activated, such as in this case, right? So if I supply the pulse, this will decrease, right? You can see the accumulated value will decrease, correct? Until it is lower than this preset value, then you can see what will happen. Okay, When this become -6, this dumb bit will be deactivated. Hence, this virtual switch will be normalized, right? Okay, see? Deactivated. This will be normalized, meaning normally open will remain open. If this switch is a normally closed, then it will remain normally closed. Okay, that's it. Thank you.